Today we're going to look at some more of these word problems on linear and angular velocity, or what we call speed. And in these problems we are going to be looking at the linear speed as being given, and we want to go backwards and find angular speed. So this is going to be a little bit different, and you really need to make sure you understand these formulas. So as we read this first problem, we see it says a bike having a wheel of 24 inches in diameter. And again, I can't stress enough that the moment you see the word diameter, go ahead and write down what the radius is. The radius is 12 inches, half of the diameter. And the reason you want to do that is so you don't forget and plug in diameter by mistake. And then it says you're going 12 miles per hour. Now miles are measured in a straight distance, so that makes it your velocity. 12 miles over hours. It says, what is the angular velocity in revolutions per second? In order to get revolutions, you need radians. In order to get radians, you need to get your units straightened out. So this is in inches, and this is in seconds. So our miles per hour is way off in what it needs to be in terms of units. So we're going to move this over here and look at how can I convert this to inches and seconds, because those are the two units that the problem needs to be in, and I have miles per hour. First, let's talk about how many is in a mile. Now, a mile would cancel out if I put it on bottom. And a mile is 5,280 feet. But I don't need feet, I need inches. So now I'm going to put a foot on the bottom to cancel out the feet. And put 12 inches on top because that's how many's in a foot. Now I've got my inches worked out. It's time to work on the hours. Now there's a couple of different things you can do. First, you could convert the hours to minutes, and then the minutes to seconds. Or you can figure out how many seconds are in an hour, which happens to be 60 times 60. So that's what we're going to do. So an hour needs to go on top to cancel out the hour over there, and 3,600 seconds is what 60 times 60 is. Now we're going to take and multiply all this together. And again, you multiply all the numbers on the top together and divide by all the ones on the bottom. So we have 12 times 12 times 5,280 divided by 3,600. So this equals 211.2 inches per second. So this is really moving. That's a lot of inches. But it's a bike, so you think, not that fast, really. But it sounds like it is, because that's a fairly large number. Now, let's talk about the velocity formula. The velocity is equal to omega times your radius over 1 rad. We know our velocity. We just found that. We know our radius. What we don't know is omega, and that's what we're going to try to get first. So 211.2 inches over seconds equals omega times our radius is 12 inches over 1 rad. So now we're going to have to solve this problem backwards. So we're going to flip multiply 1 rad over 12 inches. That way we'll have omega by itself, and our inches are going to cancel. So omega is going to be equal to radians over seconds once we figure out what this divides out to give. So divided by 12 comes out 17.6. Now 17.6 is the radians per second. Now let's look at revolution. So let's see, how do you work with that? How do you get revolutions out of radians? Well, we go back to that formula that we were looking at before, that omega is equal to revolutions over time times 2 pi radians over 1 revolution. Now what we don't know is the revolutions over time. That's what they're asking us to find, revolutions per second. So we're going to try to kind of find this one fraction here. We know omega, it's 17.6 radians per second. We just don't know how many revolutions it is, so I'm going to put a question mark there. But we do know to convert revolutions to radians, we use 2 pi rad over 1 revolution. So again, like I said before, we're working this problem backwards. So once you fill in your formula, you realize I don't know what question mark times that fraction is, so let's flip and multiply. Let's put 1 revolution over 2 pi radians times each side. So now our radians cancel out, giving us revolutions over seconds, which is what we're wanting. That's going to be, well, I probably shouldn't write it's equal to omega. I'll just put it's equal to question mark, but it really is equal to omega. Omega has 2 different units it can be in. We've just been converting it to radians the whole time because that's what you got to have, but it actually can be omega. And the answer to this question comes out 2.80 revolutions per second. So this is what the 3 problems I want to do today are like. So we're going to look at 2 more examples of this. All right, a compact disc player uses a laser to read the music from a disc. The player varies the rotational speed of the disc depending on the position of the laser. The laser on the outer edge of the disc, the player spins the disc at a slower speed of 200 RPMs. Of course, it would be faster closer to the middle because it doesn't take as long to go around the circle because the radius gets smaller. So that kind of makes sense. We're first going to focus our problem on the outer edge because that's where it starts reading the laser disc. It says that the slow speed, how many degrees does the disc turn in a minute? Through how many radians does it turn in a minute? Let's focus on radians first, because I think that's what we've been using. So omega is equal to 200 revolutions a minute, because that's what RPM stands for. RPM is revolutions per minute. And you're supposed to multiply that by 2 pi radians over 1 revolution in order to get the revolutions to cancel and give you radians. So this will be 400 pi radians per minute. So that's the speed. Now the question says how many radians does it turn in a minute? So for the angular distance, it would be 400 pi radians. Now there's a similar process for degrees. If it's 1 revolution is 2 pi radians is all the way around the unit circle, how far is it all the way around the circle in degrees? Correct, it is 360. So therefore, I can take this same formula of 200 revolutions per minute, and instead of putting 2 pi radians, I can put 360 degrees over 1 revolution, because that's the other way that you can work the question, based on how far it is around a unit circle. And so then, I multiply that together, and I get 72,000 degrees, because the revolutions cancel out, per minute, and that tells me my distance in a minute is 72,000 degrees. Let me rephrase that. Distance probably isn't the right word letter for that. Angle is that many degrees. That's how many we've turned. Alright, so let's take this a step further. In part B, it says if the diameter of the disc is 11.9 centimeters. Oh, wait a minute. What am I supposed to do every time I see the word diameter? Yes, I am supposed to find the radius. So we're going to take 11.9 and divide it by 2 and say the radius is equal to 5.95. It says find the approximate distance a point on the outer edge will get, and the slowest speed is 1 minute. Now we already know the angular speed because we found that up here earlier. So we're already halfway there. We just got to take and plug that in the linear speed formula. So let's start there. Velocity is equal to, We know our angular speed is 400 pi radians per minute. We're going to multiply that by the radius, 5.95, and that was in centimeters, over 1 radian. So now the radians will cancel out. This will give us centimeters per minute if we take 400 pi times 5.95. So 7,476.99 is our velocity per minute. Now it asks us what's the distance it went in a minute. So if I take distance equals rate times time and multiply 74,769, no, I said that wrong, 7,476.99 centimeters every minute times 1 minute, the minutes will cancel out, and your distance will just be this number in centimeters. Now, that's kind of just really obvious because it said in a minute on the unit, but if I said 3 minutes, then I'd multiply by 3 minutes. So I have to know what units I'm working with. All right, now this question has another part to it. Let's see where that's taking us. Now let's convert that to centimeters per second. So 7,476.99 centimeters per minute, we would multiply that by 1 minute 60 seconds. So we'd have to put minutes on top and the 60 seconds on bottom, and that will convert it. So we'll take this answer and divide it by 60, and that'll be 124.62 centimeters every second. So that's more than a meter stick every second. Now, the last ones, let's look at this problem. Here's your CD with your hole in the middle, right? And there's your center. It says the point on the outer edge of the circle is 2.95 from the outer edge. So here's the point where it's going to start reading, and that's 2.95 from the outer edge. Now, we also know that the diameter was 11.9 and that the radius was 5.95. But when you want to do these calculations, you need the radius to the point at which you are planning to work with. And so in this case, I need to know how far it is from here to here, because that's the radius of where it's reading right now. So I have to take and find that, and that'll be my true radius, because I don't want to read the outer edge anymore. I want to come in 2.95 from the outer edge. So 9.95, the radius, minus 2.5 gives us a new radius of 3 if I'm only going part of the way into the CD. So now we're going to say velocity is equal to 400 pi radians every minute, because it's still at that slow speed because it hasn't gone in that far, times your 3 centimeters every 1 radian. And how I know that is because that is the radius at which I am from the center. So then I'll take 400 pi times 3 and get that the velocity is 3,769.91 centimeters every minute, because the radians cancel. All right, we have one more question in which we're doing backwards again. This one was a forward one, and it's pretty simple, but the backwards ones seem to be a little bit more difficult. It says a car is moving at a rate of 50 miles per hour. The diameter of its wheels is 2.5 feet. So what's the radius? 1.25 feet. That's half of the diameter. Find the angular speed in minutes and radians per minute. Find the revolutions and per minute of the wheel rotating. So we're going backwards. We're starting with velocity, and we're going to take the formula for radius over 1 rad, plug in what we know, and solve for omega. That'll help us find angular speed, because that's omega. So first, our units aren't right, because we have 50 miles an hour, but the problem wants feet and the problem wants minutes. So let's convert. 1 mile is 5,280 feet. So that's the conversion factor I need and where I need it so that the miles will cancel. And then a minute 60 there's an hour 60 minutes, so we're going to put hours on top and 60 minutes on bottom so that the hours will cancel. And now when we work this question out, we'll have our new velocity in the units we needed. So 50 times 5,280 divided by 60 comes out to give me a velocity of 4,400 feet over minutes. We are going to put in our radius of 1.25 feet over one revolution, over 1 radian. Now that fraction can be flipped and multiplied. You always flip and multiply both calculations in order to work the problem backwards because you multiplied it all as you went before. Hold on. 1 radian over 1.25 feet. So now omega is going to be, feet are going to cancel, giving me that radian per minute that I'm wanting, that the direction said the angular speed in radians per minute. And I just take 4,400 divided by 1.25 and get 3,520 radians every minute. Now to convert that to revolutions, we go back to the omega formula, which says revolutions over time times 2 pi radians over 1 revolution. And we plug in this number we just found for the omega. And we set that equal to question mark times 2 pi radians over 1 revolution because we don't know the revolutions over time. That's what we're trying to find, that whole fraction. And when we flip and multiply 1 revolution over 2 pi radians, that makes my radians cancel. Over here, everything cancels out but the question mark. That's why you want things on diagonals. And so now we take the 3,520 and divide it by 2 pi. Now you can do that divided by 2 pi in parentheses, like this, or you can say divided by 2 divided by pi. 560.23 revolutions every minute. So now this will get you, I think, far enough to where you can work some more questions in your packet. I know that there's 2 13s and 14s, and when we get to 13 in the notes, that relates to, I think, number 13 or 14 on both of the pages. So you may want to try to get through 12 and then pick up with 13 and 14 on both of them as you see these last questions in the notes today. All right, so stop the video and work on your packet.